All right, so we learned that bonds can have be polar or nonpolar, and same thing with molecules. They can be polar or nonpolar. But just because you have a polar bond does not mean that you have a polar molecule. So let's take a look at molecule polarity. So a molecule can be polar if two things occur. So one, they must have polar bonds. So we represented that as a dipole, right? Our little arrowhead with a positive and negative end on it. And then two is that these dipoles must face in approximately the same direction. Right, so a molecule is only polar if it has polar bonds and those polar bonds are facing in the same direction. Let's take a look at what we mean by that. So here on the left, we've got carbon dioxide, and then on the right, we have water. So if we think about the bond polarities in carbon dioxide, oxygen is more electronegative than carbon. So we have a bond polarity like that and a bond polarity like that. And so if you think about those two arrows, they're facing the opposite direction. One is faced to the left, the other to the right. And so what happens is they cancel out. You can think about this as vector addition if you're into math. Otherwise, they're facing the opposite directions. They cancel out. And so this molecule is overall nonpolar. Even though it contains polar bonds, it itself is nonpolar. Another example of this, would be if they're both facing towards the middle. One is still facing towards the left, the other is still facing towards the right, so they cancel out. Or one is facing down, the other is facing up, they cancel out, that kind of thing. On the other hand, let's take a look at water. So the first thing that we have to make sure is that we're drawing our molecule in the correct shape, right? So remember, water is bent, not linear. Right? In order to judge whether a molecule is polar, we first have to draw it in the correct shape. So think Vesper. And so if we draw our dipoles like this, we've got one pointed toward the oxygen because it's more electronegative, and then another one pointed up towards this oxygen. And so what you can see here is that they face in approximately the same direction. There will be some canceling out, but overall, they're both pointing towards an upward direction. So they face in approximately the same direction. Thus, this molecule is polar, and water is indeed polar. That's a very important thing to know. Please know that water is indeed polar. And so they can be, if they're facing the same direction, right? So they could both be facing kind of upwards, maybe they're both facing kind of downwards. You can have more than two dipole arrows, but if they're facing approximately the same direction, it's going to be polar. If they're facing opposite directions, nonpolar. And then, of course, remember that carbon-hydrogen bonds are nonpolar as well.